Today is week 2, day 3. We're going to look at section 2 from chapter 1. So you'll see it says 1.2 segments. So we're going to be talking about segments today, and I know we've already talked about segments, so what could we possibly say more about it? Well, we're going to talk about the length of a segment. We've talked about what is a segment, how to name a segment, but let's talk about the length and how it's going to relate in geometry. So the first thing we're going to look at is a postulate. In geometry, we use postulates and theorems and definitions and corollaries. And you know from past experience what a definition is. It tells you what something is, what its characteristics are. So a postulate is a rule. Everything we do in geometry is based on some kind of rule. Definitions are actually a type of rule, but a postulate is a rule that is accepted without proof. Basically, postulates and theorems are terms that have a historical basis. A postulate is called a postulate only because all the mathematicians got together and talked about, hey, does this work or does this not work? And if they decided that the rule worked, and they all agreed that the rule worked, then it was called a postulate. They didn't have to prove it. They all said, yep, that works. I agree it works. We can see that it works, so it's a postulate. A theorem, which we're going to talk about later, became a point of contention. Some mathematicians said it worked, some did not. So the ones that said that it didn't work asked for proof. So the mathematicians showed them through proof that that rule worked. But today, our postulate is considered a rule with no proof. Everybody accepted it, and that was the way it was. Our postulate for today is going to use the vocabulary word adjacent. And adjacent means immediately adjoining. If you think about an apartment complex, when two apartments are right next to each other, they're adjoining. But if you think about a bunch of apartments together, one apartment at one end may not be adjoining to the other end because they don't share a wall. If you think about your classrooms, classrooms tend to share walls with other classrooms. That would be adjacent. But if the classroom's across the hall and they're not sharing anything, they just look at each other, that is not adjacent. Okay, so we're going to come back to adjacent here in a little bit. We talked about symbols earlier in the chapter, or notation earlier in the chapter. And so we are going to learn a new notation or new symbol today. So let's look at the one we already know. So we can see that's a picture of segment AB. So you would write that down as notation or symbols or shorthand as the points A and B with a segment symbol over the top. So we know that this symbol or this notation means segment AB. It is the actual physical item. So I could pick up segment AB and toss it and the dog would go catch it. I could use a ruler to draw a segment, to point out something on the board. So anything that I can physically touch is going to have the segment symbol over the top, meaning I can touch that. But you'll notice that our segment AB is 3 inches long. Now I know we can measure 3 inches with a ruler, but the measurement itself is not the ruler. It's a number, and you actually cannot touch numbers. You can touch the ruler, but you can't touch the numbers. So that's a totally different symbol. It still is going to use the points A and B because we need to know what we're measuring. We're measuring from point A to point B, but you'll notice there's nothing over the top because I'm no longer talking about the thing that I can pick up and throw. I'm talking about the fact that the ruler is a number. So the number, so no symbol over the top, just segment AB, is a symbol for the measure of segment AB. So it's actually the number, and since you can't really touch a number, we don't put a segment symbol over the top. So segment AB is the thing you can touch. Segment AB without something over the top really means the measure, so this is a number. You can add and subtract and multiply and divide with numbers, so I can add, subtract, multiply, and divide by this symbol or this notation, not the top one. So our postulate today is talking about two segments, so segment AB and segment BC here, that are adjacent. So you can see they're adjoining or touching at point B. So the segment addition postulate says if you measure each of these segments, the sum of those measures is going to be equal to the total length of the overall segment. Okay, so the sum of the measures of the two adjacent collinear, meaning in a straight line, segment is equal to the total length of the overall segment. So if we look at our picture here, there are actually three segments in the picture. There is segment AB, there is segment BC, and there is segment AC. So if I take the measurement of the first segment and I measure it, add it to the measure of the second segment, then that gives me the total measure. If you think about it like a ruler, that would make sense. So here are the first 2 inches on the ruler. Here are the next 4 inches on the ruler. So the entire ruler is 6 inches. I'm not adding segments together, I'm adding the numbers together. So what that looks like in notation is the length of segment AB plus the length of segment BC equals the length of segment AC. And that's the segment addition postulate. Please do not decide that you're going to make it a subtraction problem. You may do subtraction later on in the problem, but initially it's the segment addition postulate. There's no such thing as the segment subtraction postulate. Okay, so you'll notice this as example 0. That means if you are following along and you are taking notes, be it on your own piece of paper or on the fill-in-the-blank notes that you can find under materials, this is not an example that you have on that piece of paper. So this is simply just put down your pencil, just follow along. You don't have to write this down. So it says find the appropriate measure, and the appropriate measure is the length of FH. So all the way from here to here. So I'm sure many of you are looking at this going, yeah, 15 plus 21 is 36. Well, of course it's 36. But the goal here is to show you how you work it in geometry. Geometry is all about logic. If you don't put it on paper, if you don't argue it out, it doesn't really count. It really isn't justifying anything. So we have to start with our geometry. So the first thing we're going to do is we're going to totally ignore the numbers, and we're going to look just as the segment, and we're going to do the segment addition postulate. So the segment addition postulate says the length of FG, so we write that down, plus the length of GH, segment GH, so we write that down, equals the length of FH. And that is our geometry. That's what we write down first. Then we're going to convert to algebra. So we're going to substitute. How long was FG? 15. How long was GH? 21. How long is FH? It's not 36, ladies and gentlemen. It is what the problem actually gave us. It did not give us anything for the length of FH, so we write down the length of FH because you're only substituting in this step. You're not solving, you're substituting. Once everything is substituted, then you're going to go ahead and solve. So 15 plus 21 is 36. So 36 is the length of segment FH. So why do I make such a big deal out of this? Because I'm giving you easy numbers in the beginning to show you why mathematicians thought this should be a postulate. Yeah, you can just add 15 and 21 together and get 36. But in geometry, you have to justify your thought process. And that's what this is doing. This is justifying it through geometry. It's making the argument, why is it 36? So this problem is in your notes. This is a problem that you would write down or follow along with. And again, we are looking for a length of a segment. And that's how I know it's the segment addition postulate. And again, it's the segment addition postulate. There's no such thing as the segment subtraction postulate. Because I know somebody right now is looking at this going, well, can't I just subtract them? Yes, you will eventually subtract them, but we're going to do the geometry. So first we have the length from C to D. We write that down. Plus, then we have the length from D to E equals the length from C to E. Then we're going to substitute. The length of CD is not given, so we just write it down again. The length of DE is 17, so we substitute. Equals, and then the length of CE was given as 42. So this is your equation from algebra. And now we're going to subtract 17 from the left side and subtract 17 from the right side. So the length of CD equals 25. Again, why did we not start with subtraction? Because there's no such thing as the segment subtraction postulate. What I would like you to do is I would like you to go ahead and write down the equation that you think should go with question number 2. Not with numbers, but just the letters V, W, and X. I will give you a moment, or you can pause the video to go ahead and decide how long it's going to take you. It's up to you. Okay, so if you're not ready, go ahead and pause the video. That's fine. So let's look at this. Again, we're ignoring the numbers, we're ignoring the blue, we're just using the V, the W, and the X. So the very first thing we're going to write down is the length of V to W plus the length from W to X equals the entire length of V to X. Now we're going to substitute. So the length of VW is 2X. The length of WX is X plus 14. And the length of VX is 53. Then algebra tells me I can't have two terms with X, so I need to combine like terms. So I get 3X plus 14 equals 53. I'm only allowed to do one algebraic step at a time. Again, geometry is all about logic. So order of operations in solving an equation tells me first I need to combine like terms. Everything else I just write down. Now I need to get 3x by itself, so I will be subtracting 14x from the left and subtracting 14 from 53. So once I do that, I'll still have my 3x, but now have equal to 39. And last but not least, I need to divide by 3 on both sides. So x is 13. Oh, great, I'm done. Wait a minute. I think I'm done. Am I done? Oh, wait a minute. Let me make sure I read the question. The question says, find the length of VW. Okay, VW is 2x. The length of VW is 2x. So now I need to substitute. So the length of VW is really 2 times 13. So the length of VW is 26. Now I've answered the question. Okay, we're going to do some self-evaluation. So we're just looking at A at this point. Which equation, well, I need to fix that sentence. Which equation applies? I probably meant which equation is correct, but it applies for solving for the length of Km. And so we have three choices over here. Are you going to do Km plus KL to get the length of LM? Are you going to do the length of KL plus the length of LM to get the length of Km? Or are you going to do the length of Km minus the length of KL equals the length of LM? Which of those would you use to solve for Km using this diagram? You can either pause, or I'll give you a couple of moments to make that decision. Okay, so they all have a Km in them, the length of Km in them, so that was not a defining factor. I can tell you it's definitely not number 3. We do not have a segment subtraction postulate. It is not number 3. So we have to decide if it's 1 or 2. So K to L, the length of KL, plus the length of LM equals the entire length of Km. That's number 2. Okay, so let's look at B. Which equation is the most appropriate for the segment addition postulate? Solve for the length of UV. Solve for the length of UV. Go ahead and look at the 3 options. Okay, so number 2 looks like a good option. It says solve for the length of UV. This is definitely solving for the length of UV. The problem is it's a subtraction. There is no such thing as the segment subtraction postulate. Only addition. So basically it's number 3, but let's look at why. The length of UV plus the length of VW equals the length of the whole thing UW. So it is number 3. Please feel free to go back and watch this video again if you need extra help. And don't forget that you need to go to the next item in your Google Classroom and fill out the form for this lesson. Please feel free, and I do highly encourage you to use your own paper and pencil to do the problems on, so you could just turn your notes over and do it on the back. Do the problems. I know that I can't see your work, but please don't cheat yourself out. I want you to practice writing down the equations, substituting and solving, and then go ahead and answer it with the Google form. You're just using the answers themselves. If you have any questions, please feel free to email your teacher or to request a Zoom. Don't forget, you want to make sure you're making it to Friday's Zoom sessions where we review the week. These will eventually show up on a quiz and a test, so don't cheat yourself. Don't just fluff right over them. For any extra tutoring you might want, you can Google search this, and I'm sure you can find other videos as well to help you out. Feel free to subscribe to the Lake Havasu High School Geometry channel on YouTube so that you can get to our videos outside of Google Classroom if you need extra help in that manner. Have a great day. Best of luck. Talk to you later.